video is from Hillsar English Medium School.
Welcome student, Standard 9, Subject Science. Lesson 2nd is Matter Around Us, Pure, Part 3. In the last part, 1st and 2nd, we saw different substances, solutions and about colloids also, and we were discussing about the Tyndall effect. This Tyndall effect can be observed when a sunlight passes through the canopy of dense forest. Dense forest है, canopy है, thick canopy है, trees की, leaves की, अगर उसमें छोटे छोटे गैप्स होते हैं, उसमें से जब सनलाइट पास होती है, that is nothing but the Tyndall effect. In the forest, the mist contains tiny droplets of water, which acts as the particles of the colloid dispersed in the air. So it is dispersed through the small droplets which are in the air. Now let's move towards the properties of colloid. A colloid is a heterogeneous mixture. जैसे कि हमने पहले सॉल्यूशन का देखा, it was homogeneous, but the colloids it is heterogeneous mixture. The size of the particles of the colloid is too small to be individually seen by naked eye. जो particles होते हैं ना colloid में suspended, जो settle नहीं होते, they are somewhat big and small inside, we cannot see. Colloids are big enough to scatter a beam of light passing through it and make its path visible. So colloid, it has a Tyndall effect, so it can scatter the light. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration. जैसे कि solution में जो कुछ भी solute होता है, it can be separated by it cannot be separated, but here also the suspended particles or the colloids, it cannot be separated by filtration, but a special technique of separation known as centrifugation we can use, जिसकी वजह से centrifuge machine उसमें use करते हैं, to based upon the principle of centripetal force, where जो मशीन वो घूमती रहती है, based upon its weight volume it gets settled down. The components of a colloidal solutions, they are the dispersed phase and the dispersion medium. जैसे कि हमने सॉल्यूशंस में देखे थे, सॉल्वेंट एंड सोल्यूट होते हैं, राइट. सो हियर द डिस्पर्स्ड फेज एंड डिस्पर्शन मीडियम होता है. सो सॉल्वेंट हियर इज़ अ डिस्पर्शन मीडियम, जो लिक्विड फॉर्म में जनरली हम बोलते हैं ना, जैसे वाटर एंड शुगर लें, तो शुगर इज सोल्यूट एंड वाटर इज सॉल्वेंट. हियर the dispersion medium is a solvent and dispersed phase is solute, but here they are given the specific name. The solute-like components or the dispersed particles in the colloid form, we call it a dispersed phase. जो solute होते हैं mix हुए, that we call dispersed phase. And the components in which the dispersed phase is suspended, जिसमें ये suspended particles है, that medium is called dispersing medium. Colloids are classified according to the state, that is solid, liquid or gaseous state में colloids present होते हैं. So based upon its dispersing medium and dispersed phase, they are categorized, and few of the examples are given in table 2.1. So from this table you can see that they are very common in everyday life. Let's see the examples. Here in this 3 columns are given. First is dispersed phase, नेक्स्ट डिस्पर्शन मीडियम एंड टाइप जो दिए उनको क्या बोलते हैं. पहला क्या है, डिस्पर्स फेज इज लिक्विड. डिस्पर्शन मीडियम अगर गैसियस होगा, मतलब गैस में जब हम लिक्विड डालते हैं, दैट इज़ अ टाइप ऑफ एरोसोल, वी कॉल इट अ एरोसोल. इफ डिस्पर्स फेज इज सॉलिड, मतलब सोल्यूट जो है सॉलिड है, और डिस्पर्सिंग मीडियम जो है सॉल्वेंट इज गैस, वी कॉल इट एज एरोसोल. डिस्पर्स्ड फेज इज गैस एंड लिक्विड के अंदर वो डिस्पर्सिंग मीडियम है, वी कॉल इट फोम उसे बोलते हैं. Dispersed phase is liquid, dispersing phase is also liquid, that is emulsion. For example is milk. Solid and liquid अगर हो तो we call it sol. Gas is a dispersed phase and solid is a dispersing medium, it is again a foam. Liquid solid हो तो it is gel. Solid is solid sol. Now let's move to the next page. Let us see the different methods how to separate the different components of the mixture. कैसे हम अलग अलग components से mixture को separate कर सकते हैं. We have learned that most of the natural substances are not chemically pure. ये chemically pure नहीं होते, अलग अलग substance एक साथ आके chemical bond बन के वो बनते हैं. Different methods of separation are used to get individual components from the mixture. मिक्सचर में जो अलग अलग components है उसको separation करके individual component हम मिला सकते हैं. Separation makes it possible to study and use the individual components of the mixture. इस तरीके से हम अलग अलग components को उसको study कर सकते हैं. Heterogeneous mixtures can be separated into their respective constituent by simple physical method like hand picking, sieving, filtration that we use in our day-to-day life, right? जो हेट्रोजीनियस मिक्सचर होता है जैसे कि दाल उसमें कुछ कंकड़ होते हैं, स्टोन्स होते हैं, इट कैन बी इजीली सेपरेटेड जस्ट बाय हैंड पिकिंग और सीविंग. But sometimes we need to use special techniques for the separation of these components of the mixture. Let us move towards the first topic. How can we obtain colored component that is derived from blue or black ink? Blue ink और black ink से हमें जो ink को कलर जिसकी वजह से आता है that colored component blue और black color कैसे हम मिला सकते हैं? See the activity. Fill half a beaker with water. Waters लेना है beaker में. Put a watch glass on the mouth of the beaker. See the picture given over here. उसमें जैसे बीकर के ऊपर एक वॉच ग्लास रखिए. वॉच ग्लास क्या होती है? एक ग्लास की प्लेट होती है, उसके ऊपर रख दी है. पुट फ्यू ड्रॉप्स ऑफ इंक ऑन द वॉच ग्लास. उसके ऊपर इंक के जो ड्रॉपलेट्स ड्रॉप्स थोड़े 2-3 डाल दिए हैं. नाउ स्टार्ट हीटिंग द बीकर. बीकर को नीचे से स्पिरिट लैम्प है या फिर बंसन बर्नर है उसे हीट करना है. यू विल सी दैट इवेपोरेशन इज टेकिंग प्लेस फ्रॉम द वॉच ग्लास. वॉच ग्लास में लिक्विड है. कौन सा लिक्विड है? इंक लिया है. एंड सो वी सी सम फ्यूम्स कमिंग आउट ऑफ दिस इंक. दैट इज द इवेपोरेशन प्रोसेस हैज स्टार्टेड. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. जैसे फ्यूम रुक जाए you will stop heating. Observe carefully and record your observation. तब आपको रुकना है और observation लेना है. So what do you think? What is evaporated? It is the solvent in which that ink is dissolved is evaporated. That is nothing but the water. Is there a residue on the watch glass? Yes, the color of the ink remain as it is on the watch glass. What is your interpretation? Is the ink single substance or pure, or is it is a mixture? So ink it is a single substance which is dissolved in its solvent. So it is a mixture of dye with water, color dye with water. Thus we can separate the volatile component as solvent from its non-volatile solid by method of evaporation. This is a simple method of evaporation we have seen. Now see the next sub point is how can we separate cream from the milk. Nowadays we get full cream or tone and double tone varieties of milk packed in polypacks और टेट्रा पैक्स इन द मार्केट. जब हम मार्केट से मिल्क लाते हैं पैकेट में होता है. सो इट इज़ रिटन फुल क्रीम और स्कीम्ड और टोन मिल्क और डबल टोन मिल्क. दिस वैरायटी ऑफ मिल्क कंटेन डिफरेंट अमाउंट्स ऑफ फैट प्रेजेंट और इट हैज़ रिटन हाउ मच फैट इट इज़ 6% और 4 और 3 फैट जैसे उसका नंबर होता है. इट शोज द कंटेंट ऑफ फैट इन दैट. So activity is given to separate cream from the milk. Take some full cream milk in a test tube. फुल क्रीम मतलब ऐसे कैसे वो मिल्क लेना है जिससे क्रीम जो होता है उसके अंदर का फैट सेपरेट नहीं किया. एंड सेंट्रीफ्यूज इट बाय यूजिंग सेंट्रीफ्यूजिंग मशीन फॉर 2 minutes. उसको घुमाना है मशीन को. इफ़ सेंट्रीफ्यूजिंग मशीन इज़ नॉट अवेलेबल इन अ स्कूल यू कैन डू दिस एक्टिविटी एट होम बाय यूजिंग मिल्क चर्नर यूज इन द किचन. जब मिल्क चर्नर होता है ना जिससे हम घुमा के दही में से कर्ड में से जो ये होता है ना मक्खन बाहर निकालते हैं ऊपर आ जाता है. दैट इज़ मिल्क चर्नर. वी कैन यूज़ दैट. इफ़ यू हैव अ मिल्क डेयरी नियर बाय visit it and ask how they are separating cream from the milk and how they are making cheese or the paneer from the milk. Now answer these questions. What do you observe on churning the milk? When we churn it, what do you observe? The milk get completely mixed. It rotates around. Whatever the cream present in that, it comes up. Explain how the separation of cream from the milk takes place. This is how, with the help of centrifugal force, whatever the density wise the separation occurs. Sometimes the solid particles in the liquid are very small and pass through the filter paper. For such particles, the filtration techniques cannot be used for the separation. Such mixtures are separated by centrifugation. For where the Filtration is not possible, is not effective. That time we can use centrifugation. The principle is the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. जब हम जैसे मिक्सर होता है उसमें होता है सिमिलरली यहाँ पे भी जो डेंस होता है डेंसर पार्टिकल्स दे आर सेटलिंग एट द बॉटम, नीचे चला जाता है लाइटर पार्टिकल्स इट कम्स अप. What is the application of this centrifugation technique? It is used in diagnostic laboratories for blood and urine test. Blood urine test के लिए use होता है. Used in dairies and home to separate butter from cream. Used in a washing machine to squeeze out water from wet clothes. आपने ऑब्जर्व किया वॉशिंग मशीन में when it is spinning उसमें से पूरा पानी निचोड़ लिया जाता है. So centrifugation process is used. This principle is based. The machine is based on this principle. Now let's move to the next subtopic. How can we separate a mixture of two immiscible liquids? Now what is immiscible liquid? Two liquids which are not getting mixed completely, which are forming colloid. Like example is milk. Let us we can also say example is oil and water. Let us try to separate kerosene oil from water using separating funnel. Separating funnel, you can see the picture, this shape, the funnel is given, that is nothing but separating funnel. Put the mixture of kerosene oil and water in the separating funnel. Let it stand undisturbed for some time so that separate the layers of the oil and the water are formed. You can observe literally two layers, one up is the kerosene oil and the down is water. Now close this, open the stop cock of the separating funnel. जो नीचे कॉक दिया stop cock वो open करेंगे so that whatever the water is at the down layer, it will lower layer, it will come out. And close the stop cock of separating funnel as the oil reaches the stop cock. क्या करना है हमें वाटर निकाल लेना है. सेकेंड लेयर इज रिमेन ऑफ स्टॉक kerosene oil can be separated in the other container. This is how we can separate two immiscible liquid. Now what are the applications of this process? First application is to separate mixture of oil and water. Oil water का जो mixture होता है उसको separate करने के लिए. In the extraction of iron from its ore, जहाँ पे आयरन रहता है खदान होती है ना आयरन की, सो उसमें से हमें आयरन सेपरेट करना है बिकॉज देयर इट इज़ फॉर्म ऑफ अ मिक्सचर. The lighter slag is removed from the top by this method to leave the molten iron at the bottom of the furnace. जो furnace में two layers form हो जाएगा, एक slag होता है and molten iron separate हो जाता है. The principle is that the immiscible liquid separates out in the layer depending upon their densities. So you can guess that the higher density liquid it will form the lower level in the separating funnel, and lower density it will form the upper layer. Let us move towards the next subtopic. How can we separate a mixture of salt and camphor? Camphor जो होता है ना उसे हमें salt से separate करना है. We have learned in chapter 1 that the camphor changes directly from solid to gaseous state on heating. What do we call that is volatilization. The camphor जो होता है ना सॉलिड से गैस में डायरेक्टली कपूर जिसे हम कहते हैं ट्रांसफ़र हो जाता है. सो टू सेपरेट सच मिक्सचर दैट कंटेन अ sublimation volatile components from a non-sublimable impurities. So this is how by sublimation process we can separate camphor from any other impurities present in that. The sublimation process is used for that. Some examples of solids which sublime are ammonium chloride, naphthol, anthracene and iodine also. Iodine is also one of the example of sublimating substances. So for that one activity is given separation of camphor and salt by sublimation. इसके लिए क्या किया है, एक चाइना डिश में कैम्फर लिया है, सॉल्ट का मिक्सचर लिया है. On that inverted funnel is kept. At the other end it is closed with a cotton plug and it is heated from the down. So whatever the vapors of camphor is, it will saturate or it will settle on the walls of the funnel and salt will remain as it is. Now let's move on the next page. Next topic is there. Is the dye in black ink is single color or मतलब जो dye हम यूज़ करते हैं वो black color का है, right? वो that is made of a single color or some many other colors also. present in that. Activity is given. Take a thin strip of filter paper, draw a line on it using a pencil approximately 3 cm above the lower edge. नीचे से 3 cm पे एक लाइन खींचनी है हमें. Put a small drop of ink that is water soluble, that is from a sketch pen और फाउंटेन पेन. एक छोटा डॉट देना है वहाँ पे, स्पॉट लगाना है इंक का. Now let that ink dry. Then further lower the filter paper into the jar or a glass beaker or test tube containing a water so that a drop of ink on the paper is just above the water level. ठीक है ना. हमें क्या करना है, वो जो पेपर है ना उसको वो वाटर में डीप कर देना है, मगर जो डॉट हमने लगाया ना इंक का वो थोड़ा ऊपर ही रहना चाहिए. एंड आफ्टर दैट सी द setting is given, the arrangement is given in the picture. Now watch carefully as the water rises up on the filter paper. Record your observation. जैसे पानी ऊपर ऊपर चलता जाएगा, it carries ink along with it, and the component, if they are present, they will get separated through that. The ink that we use has a water as a solvent, and the dye is soluble in that water. As the water rises on the filter paper जैसे जैसे वो जो पानी है वाटर बढ़ता जाएगा, along with it the dye particles also come up, move up. Usually this dye is a mixture of 2 or more colors. The colored components that is more soluble in water, it rises faster, and in this way the color gets separated. जो कलर कंपोनेंट है वाटर में ज़्यादा सोल्यूबल है वो सबसे आगे बढ़ेगा कंपेयर टू द अदर वन. सो यू कैन डू दिस एक्टिविटी एट होम. So this process of separation of components of a mixture is known as chromatography. So chroma in Greek means color. So separating color. This technique was first used for the separation of colors. So this name was given. Chromatography is the technique used for separation of those solutes that dissolve in the same solvent. मतलब ऐसे ही कंपोनेंट सेपरेट होंगे जो हमने जो सॉल्वेंट लिया, यहाँ पे वाटर लिया था, वैसे अलग अलग सॉल्वेंट्स होता है. एसीटोन अल्कोहल का मिक्सचर हो सकता है, क्लोरोफॉर्म का मिक्सचर हो सकता है. सो अलग अलग सॉल्वेंट होते हैं, और वो सॉल्वेंट में अगर वो कंपोनेंट डिसॉल्व हो रहा है तो ही वो सेपरेट होगा. विद द advancement in the technology, your techniques of chromatography that have been developed. You will study about chromatography in your higher classes. Higher classes में आप different types of chromatography study करोगे. See what are their application to separate colors in dye. dye में अलग अलग कलर्स है उसको सेपरेट करने के लिए यूज़ होता है. पिगमेंट्स फ्रॉम द नेचुरल कलर्स, नेचुरल कलर्स में जो पिगमेंट्स है उसको सेपरेट करने के लिए होता है. या फिर जो क्लोरोफिल होता है ना, राइट, क्लोरोफिल प्रेजेंट इन द लीफ, उसमें जो अलग अलग क्लोरोफिल के टाइप है उसको सेपरेट करने के लिए हो सकता है. ड्रग्स फ्रॉम द ब्लड, ब्लड में अगर ड्रग्स हो तो कौन से ड्रग का इस्तेमाल किया गया है वो फाइंड आउट करने के लिए the chromatography is generally used. Now let's move to the next topic. How can we separate a mixture of two miscible liquid? The जो दो लिक्विड मिसिबल कम्प्लीटली एक दूसरे के साथ मिक्स हो गए उसको सेपरेट कैसे करना है. सी द एक्टिविटी इज गिवन ओवर हियर. लेट अस ट्राई टू सेपरेट द एसीटोन एंड वाटर फ्रॉम देयर मिक्सचर. एसीटोन एंड वाटर का जो मिक्सचर है जो कम्प्लीटली सोल्यूबल है, एक दूसरे के कम्प्लीटली मिक्स हो गए हैं, उसको सेपरेट करना है. टेक अ मिक्सचर इन अ डिस्टिलेशन फ्लास्क. डिस्टिलेशन फ्लास्क पिक्चर में दिया गया है. एंड फिट इट विद द थर्मोमीटर, क्योंकि दोनों का जो बॉइलिंग पॉइंट है वो या मेल्टिंग अलग अलग है. therefore विद द हेल्प ऑफ थर्मोमीटर हम अलग अलग उसको हीट करेंगे एंड विल गेट सेपरेटेड आउट. अरेंज द apparatus as shown in the figure 2.9. Heat the mixture slowly, keeping a close watch on the thermometer. The acetone vaporize the condense in the condenser and can be connected from the condenser outlet. एक बार सबसे पहले जो एसीटोन वेपराइज होगा वो कंडेंसर से जाएगा. वहाँ पे कंडेंसर विथ कोल्ड वाटर रनिंग है, विच बिकॉज ऑफ दैट द टेम्परेचर डिक्रीजेस एंड वेपर्स ऑफ एसीटोन टर्न इनटू द लिक्विड एसीटोन विच कैन बी कलेक्टेड आउटसाइड. And at the end in the flask the water remains, that is distillation flask. This method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. अलग अलग दोनों के भी boiling points होने चाहिए. To separate a mixture of two or more miscible liquids for which the difference in the boiling point is less than 25 केल्विन से भी उनकी जो बॉइलिंग पॉइंट में जो डिफरेंस है वो कम है, और टू देन मोर लिक्विड से वी कैन यूज़ fractional distillation method. Which method we can use? It is a fractional distillation. For example, for the separation different gases from air, different fraction or the fractions from the petroleum products, etc., we can use this. The apparatus is similar to that of the simple distillation, except that the fractional column is fitted in between the distillation flask and condenser. So different liquid get separated out at a different temperature. A simple fractional column is tube packed with a glass base. The beads provide a surface for the vapor to cool and condense rapidly. So जो ये bead है वो अलग अलग temperature में heat हो जाएगी and cool हो जाएगी. So accordingly the different fractions can get separated. Now let's have a look over a video to get more deep ideas about these different methods of separation. Your homework is to write a note on each on this method of separation and its diagram. Goodbye.
Separation of mixtures using different techniques. Separating funnel. To do this experiment, we require a separating funnel, stand with a clamp, mixture of oil and water, filter funnel, and beakers. Take a filter funnel and place it on the mouth of the separating funnel, which is clamped to a stand. Pour the mixture of oil and water into the separating funnel through the filter funnel. Oil and water will appear as separate layers. Remove the filter funnel from the separating funnel and close the separating funnel using a lid. Take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Place the separating funnel in the stand and allow the two liquids to separate completely. Oil forms the top layer and water forms the bottom layer. Take a beaker and place it below the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully onto the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. The immiscible liquids separate out in layers depending on their densities. The denser liquid will fall to the bottom, forming the lower layer, and the lighter liquid forms the top layer. Water is denser than oil. Simple distillation. We require a mixture of acetone and distilled water, stand with clamp, heating mantle, and porcelain chips. Take a mixture of acetone and distilled water and pour it into a 250 ml RB flask or distillation flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips using a spatula and put it in the RB flask to avoid bumping while boiling. Connect a distilling head to the RB flask and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask or receiver flask to the vacuum adapter. Take an ice bath and place the RB flask in the ice bath. Connect a rubber tube between the tap and the inlet of the condenser to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle to 56 degrees and heat the mixture to boil. At 56 degrees, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in a liquid form. Water is left behind in the distillation flask. Simple distillation is used for the separation of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Acetone boils at 56 degrees and water boils at 100 degrees. Fractional distillation. We require a mixture of methanol and ethanol, stand with a clamp, heating mantle, and porcelain chips. Take a mixture of methanol and ethanol and pour it into a 250 ml RB flask or distillation flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips using a spatula and put it into the RB flask to avoid bumping while boiling. Connect a fractionating column to the RB flask. Connect a distilling head to the fractionating column and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask or receiver flask to the vacuum adapter. Take an ice bath and place the RB flask in the ice bath. Connect a rubber tube between the tap and the inlet of the condenser to allow cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle to 65 degrees and heat the mixture to boil. At 65 degrees, methanol vaporizes and the vapors first rise through the fractionating column and pass through the condenser. Condensation occurs and methanol is collected in the receiver flask in the liquid form. Remove the RB flask containing methanol and connect a new RB flask to the vacuum adapter. Again, set the temperature of the heating mantle to 78 degrees and heat the contents of the RB flask. At 78 degrees, ethanol vaporizes and the vapors rise through the fractionating column and pass through the condenser, and condensation takes place and ethanol gets collected in the receiver flask in a liquid form. Fractional distillation is used for the separation of two or more miscible liquids for which the difference in boiling points is less than 25 K. Centrifugation. We require milk, distilled water, centrifuge tubes, centrifuge machine. Take a centrifuge and fill 3/4 of it with milk. Place the centrifuge tube in one of the holes of the rotor of the centrifuge tube. Take another centrifuge tube and fill 3/4 of it with distilled water. Place it opposite to the first centrifuge tube to balance the centrifuge machine. Then, Close the centrifuge machine and centrifuge the milk for 2 minutes and stop the machine. Take the centrifuge tube containing milk from the machine and observe the changes. The fat rises to the top, resulting in a cream layer at the top and skim milk, that is plasma phase of milk, at the bottom. The denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Chromatography. We require a mixture of red and blue inks, distilled water, isopropyl alcohol, Whatman filter paper strip, that is 20 by 2 centimeters, capillary tube. Take a Whatman filter paper strip 20 by 2 centimeters. Draw a line with a pencil above 4 centimeters from one end. Draw another line lengthwise from the center of the paper and name the point at which two lines intersect as P. Take a capillary tube. Dip it into the beaker containing a mixture of red and blue ink and take the mixture using the capillary tube. Put a drop of the mixture of red and blue inks at the point P. Allow it to dry in open air. Again, take mixture of red and blue ink using the capillary tube. Put another drop on the same spot and dry it again so that spot is rich in mixture. Take 5 ml of distilled water in a measuring cylinder and pour it into a chromatographic chamber. Then take 5 ml of isopropyl alcohol in a measuring cylinder. Pour it into the chromatographic chamber containing distilled water. Mix the contents of the chromatographic chamber using a glass rod. This mixture is used as the solvent. Take the filter paper and suspend the filter paper vertically in the chromatographic chamber containing solvents in such a way that the pencil line remains about 2 centimeters above the solvent level. Close the chamber and keep it undisturbed for some time. Notice the rise in solvent along with the mixture of red and blue ink. When the solvent has risen about 15 centimeters, you will notice two different spots of blue and red colors on the filter paper. Take the filter paper out of the chamber and mark the distance that the solvent has raised on the paper with a pencil. This is called the solvent front. Dry the paper and put pencil marks in the center of the blue and red spots. Measure the distance of the solvent front from the original line and the distance of the two spots from the original line. Calculate the RF values of the blue and red inks by using the formula.